Okay, trig identities. So I'm going to be using the definitions of sine, cos, and tan that I went over in my previous video. That sine is the y-coordinate, cos is the x-coordinate, and tan is the slope on the unit circle. So if you don't know what I'm talking about, go back to my previous video. Now I'm going to be focusing mostly on these identities, but first I thought I'd go over some other ones that you can easily get from the unit circle. Now first of all, since tan theta is the slope, which is rise over run, or the y-coordinate divided by the x-coordinate, and remember that sine theta is the y-coordinate, so it's sine theta over, and then the x-coordinate is cos theta. So that's a really important one. You're going to be using that a lot. And second of all, because this is a circle with a radius of 1, the equation of that circle is x squared plus y squared equals 1. If you haven't done equations of circles before, just think of that in terms of Pythagoras' theorem. So if you imagine a little right angle triangle there, that side's y, that side's x, and that's 1. So that gives you that equation. Now because x is cos theta, this is the square of cos theta, which we write as cos squared theta. Because if we wrote cos theta squared, we might think that means like the theta is squared. You can write it with brackets around it, but we sort of use that as a shorthand. So x is cos theta, so we plug that in, and the y is sine theta, so cos squared theta plus sine squared theta equals 1. That's another really important one. It's also important to be able to rearrange this to make cos squared theta equals 1 minus sine squared theta, or sine squared theta is 1 minus cos squared theta. So those are very important to be able to get that as well, because you may need to write cos squared theta in terms of sine squared theta, or vice versa. Another thing that we can do with this equation is divide both sides of it by cos squared theta. And that's going to give us 1 plus sine squared theta over cos squared theta equals 1 over cos squared theta. Now, since tan is sine over cos, this is just tan squared theta. And we have a special symbol for 1 over cos. We call that sec, or secant. So that's going to be sec squared theta. And another thing that we can do is divide both sides of this by sine squared theta. So that's going to give us cos squared theta over sine squared theta plus 1 is 1 over sine squared theta. Now, cos over sine, we have a special word for that as well. That's cot squared theta. And the 1 over sine, we can call that cosec. So that's cosec squared theta. Now, I don't really have a special way of remembering that 1 over sine is cosec and 1 over cos is sec. I just sort of think of it in terms of this pair has the co bit on this one and not on this bit, and this one has the co on this bit and not on this bit. Somehow that makes sense to me, but you can come up with whatever ways to remember that you like. If you have a neat way of remembering that, then let me know in the comments. Okay, so those two, you may need to use those as well at some point. Now the next thing I want to show you isn't really anything to do with the unit circle, but just a neat way of working out these identities, which is just to know what the co in cosine, cotan, and cosec actually means. What it means is it's referring to the complementary angle, which means like 90 minus the original angle. So cosine actually means sine of the complementary angle, and that gives you that cosine of theta is sine of 90 degrees minus theta. And likewise, cotan means tan of the complementary angle. So cot theta is tan of 90 minus theta. And cosec is sec of the complementary angle. So cosec theta is sec 90 minus theta. Now you can also get these ones, which if you think about like cos of 90 minus theta, remember cos is sine of the complementary angle. So what's the complement of this? Well, you can think of it as 90. You can think of it algebraically like 90 minus theta. If you simplify that, that just gives you theta. So cos 90 minus theta is sine theta. You can also think of it just like geometrically, that the complement of the complement is just the original angle. So then you can similarly get these other ones as well, that tan theta is cot of 90 minus theta and sec theta is cosec of 90 minus theta. I just want to explain some things about cot theta, how the various identities regarding cot relate to each other. So by definition, cot theta is the tan of the complementary angle. So it's tan of 90 degrees minus theta. And if we replace the tan with sine over cos, then it becomes sine of 90 minus theta over cos 90 minus theta. And what's another way of writing sine 90 minus theta? Remember that cosine is sine of the complementary angle, which is exactly what we have here. So this is cosine of theta. And on the bottom, we have the cosine of 90 minus theta. Now, cosine being the sine of the complementary angle, we have the sine of the complement of 90 minus theta, which is actually just theta. Complement of the complement is just the original angle. So the bottom there just becomes sine theta. So that explains why cot theta is cos theta over sine theta. Now, you can also think of that as being the reciprocal of sine over cos. So you could say that it's 1 divided by sine theta over cos theta, which is why you'll also see cot theta being expressed as 1 over tan theta. So there's sort of 3 different ways of thinking about what is cot theta. You can think of it as tan 90 minus theta, you can think of it as cos theta over sine theta, or you can think of it as 1 over tan theta. You really need to be able to use all of those at different times. Now, moving on to working out what these are, I've just picked a random angle theta. I've put it in this quadrant, but you could put it anywhere in the unit circle. It's just going to be a little bit easier if we use an angle that's in here. So first of all, let's work out where negative theta would be on the diagram. So remembering that positive angles go around this way, but negative angles go around this way, negative theta is going to be down there. Now let's think about the cos and sine of this angle. So remember that cos is the x-coordinate and sine is the y-coordinate. So the cos of that angle is the x-coordinate, which you can see is about 0.9, and you can see it's exactly the same as the x-coordinate at this point. They're both around 0.9. So the cos of negative theta is going to equal the x-coordinate at this point, which is the cos of theta. So cos negative theta equals cos theta. For the sine, which remember is the y-coordinate, you can see the y-coordinate here is about negative 0.4, and up here it's positive 0.4. So they're equal magnitude but opposite. So we can say that sine of negative theta equals negative sine theta. Now moving on to the tan, that is the slope of these, or if you like you can extend those lines so that they hit this one, and then the tan is the y-coordinate of these points. So y-coordinate here is tan of negative theta, y-coordinate here is tan of theta. So what's the relationship between those? Well, you can see that this one is negative, like that's around negative 0.5, whereas this one is positive, that's around positive 0.5. So they're equal but opposite, so we can say that tan of negative theta is negative tan theta. All right, let's see if we can simplify these. So first thing you want to do is work out where in that diagram is 180 degrees minus theta. So as usual, pause the video whenever you feel like you can figure out the answer. So think of 180 minus theta as 180 and then go back theta. So that's going to be there. And let's think about the cos and sine of that angle. So cos is the x-coordinate. You can see the x-coordinate here is about negative 0.9, and the cos of theta is a positive 0.9 approximately. So there equal but opposite. So we can say that cos 180 minus theta equals negative cos theta. For the sine, that's the y-coordinate, and you can see that the y-coordinates are the same, like they're both around 0.4. So we can say that sine 180 minus theta is just equal to sine theta. Okay, now moving on to the tan. Let's extend those lines. So tan is the y-coordinate. So tan theta is here, tan 180 minus theta is here. You can see that this one's about negative 0.5, this one's about 0.5. So they're equal but opposite. So we can say that tan 180 minus theta is negative tan theta. Let's have a go at 180 plus theta. Where is that going to be on the diagram? So if you think of it as 180 plus the theta, which I've made that much, that's going to end up down there, like that. Now, what is the cos and sine of that angle? So cos is the x-coordinate, which you can see here is negative, whereas this one is positive. So cos 180 plus theta is negative cos theta. And the sine is also negative here. So this one's about negative 0.4, whereas the sine of theta was positive 0.4. So they're equal and opposite. So sine 180 plus theta is just negative sine theta. Now for the tan, you can really see straight off the bat that those two lines, that one and that one, have the same slope. So tan 180 plus theta is just equal to tan theta. If you like, you can extend them both to there, and they're both just the same point with the same y-coordinate. So tan 180 plus theta is definitely just equal to tan theta. All right, let's see how much of that you remember. Now let's say we've got an equation like cos theta plus sine squared theta equals 1, and we want to solve that for theta. So what we would want to do first is write it in terms of just cos theta. So we want to replace the sine squared theta with something that's just in terms of cos theta. How do we do that? So as usual, pause the video whenever you can think of the answer. It doesn't really help your skills very much if you just watch someone else doing something. You have to try it yourself. So if you remember, from x squared plus y squared equals 1 being the equation of the unit circle, from that you can get cos squared theta plus sine squared theta equals 1, and then if you move the cos squared theta over the other side, you would get sine squared theta is 1 minus cos squared theta. So you can sub that in there and get cos theta plus 1 minus cos squared theta equals 1. So if you're curious about how you would actually solve that, you could cancel the 1s from both sides, like subtract 1 from both sides. And you've got cos theta minus cos squared theta equals 0, and then you can factorize this and make it cos theta times 1 minus cos theta equals 0, and then that becomes, when you've got two things multiplied together equal to 0, that means one of them has to be 0. So either cos theta equals 0, or the 1 minus cos theta equals 0, which would give you cos theta equals 1. Now I'm going to talk about how you work out theta from these in later in this series, so stay tuned for that. But if you're curious about it now, from that you would get that theta is equal to 0, and this one would give you theta is 90 or 270. Or if you're working in radians, you would get 0, pi on 2, or 3 pi on 2. Let me actually talk about radians, because once you start to get into calculus, radians become really important. So what I would just memorize for radians is that pi means 180 degrees. And then that gives you the pi on 2, well, that's half of that. That's 90 degrees. And then 3 pi on 2 is 3 times that, so that's 270. So that should give you a clue for how to start out with radians. But I would just memorize that pi is 180 degrees. So let's try another one. Let's try simplifying sine of, let's make it pi minus theta. How would you do that? Now remember that this just means sine of 180 degrees minus theta. Now the way that I would work that out is I would picture or draw for myself a little diagram like this. I'd stick in a theta, that's my angle theta, and then 180 minus theta is here. And sine means the y-coordinate of these points, and you can see that they have the same y-coordinate. So y-coordinate here is sine theta, y-coordinate here is sine 180 minus theta, so this just equals sine theta. Let's try another one. Let's try simplifying sine of pi on 2 minus theta. So, do you remember what pi on 2 is in degrees? If you're not familiar with radians yet, it might help to translate this over. So that is 90 degrees minus theta. Now, do you remember what I said about about what that means at the start of a trigonometric function? So cosine means sine of the complementary angle, which is what we have here. This is the complement of theta. So this is just cos theta. How about simplifying tan pi plus theta? If you like, you can translate this into degrees. So that's tan of 180 plus theta. Now the way that I would work that out, I don't memorize these at all. I just picture in my mind or draw for myself a little diagram where I stick on a theta. It doesn't really matter where you put it, but it's easier if it's in here. And then 180 plus theta is 180 plus theta more, so that's down there. And the tan is the slope. You can see that the slope of those two bits is the same, or if you like, you can extend it to there, and they both have that same y-coordinate there. So that means that tan of 180 plus theta is just equal to tan theta. So that's how you simplify that one. Now suppose we want to solve an equation like this. What you would want to do first is just write everything in terms of tan theta. So how do we do that? Well, tan of negative theta, again, I don't memorize what these things are at all. I just draw myself a little diagram or picture it in my head if I can. So if theta is there, negative theta is going to be down here, and you can see the tan of those two angles are equal but opposite. So that means tan of negative theta is negative tan theta. Now for the sec squared, the way that you get that is from the cos squared theta plus sine squared theta equals 1 equation. You can divide both sides of that by cos squared theta, and that gives you 1 plus tan squared theta equals sec squared theta. So we can sub this into here, and we will get negative tan theta plus 1 plus tan squared theta equals 2. Now that's a quadratic equation that you can use to solve for tan theta. Okay, let's try simplifying this one. So if you want to write this in terms of degrees, that might help if you're not too comfortable with radians. So this means cos 90 degrees minus theta times the cot negative theta. Now, we could express that as 1 over tan negative theta, but it might be easier if we express it as cos negative theta over sine negative theta. So now what can we do with that? The cos 90 minus theta, if you remember, that makes sine theta, because we've got cos of the complement of theta. And over here, if you just draw yourself a little badly drawn unit circle, pick a theta, and then where's negative theta? Down here. Cos is referring to the x-coordinate. You can see the two x-coordinates here are the same. So cos of negative theta is just equal to cos theta. And sine of negative theta is the y-coordinate, which you can see they're equal and opposite. So sine of negative theta is negative sine theta. And then we can do some simplification here. If we've got sine theta and then we're dividing by sine theta, they're going to cancel each other out. and you've got like cos theta divided by -1, that just makes negative cos theta. So that's that one simplified. Next time in this series, I'm going to be talking about these special angles. So things like, what is sine of 150 degrees, what's tan of -45, all those things will be answered in the next video. So stay tuned for that one. And if you like this video, then give it a thumbs up and consider subscribing if you haven't already.